Hello, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight we're going to be looking at the homework for Math 1, Worksheet 3.4. Remember, each of the problems in the homework help mirrors the problems on your actual homework. So if you have a problem with a particular problem, look that problem up, fast forward the video of that problem, and this should help you solve that problem. Okay, so let's get started. Problem 1 says to list the slope and 1 point on the following graph. Now, if you look at this equation here, you'll notice that it's already in what we call the point slope form, which looks like this: y minus a point, y1, equals the slope times x minus a point 1. So when I line this up, you see I can see y minus 10 equals 5/9 times x plus 6. Now immediately we can see, all right, the slope m is 5/9. We can also see that the point, which is x1, y1, is going to be, the second part's going to be right here. It's going to be, notice, minus y1, so I have minus 10. So my y is going to be 10. On the other side here, though, this is a plus 6, so I need to change that to a minus. So I might write it this way. This stays the same. And here, instead of writing plus 6, I'm going to write x minus 6. Remembering that subtracting a negative becomes plus, but it also tells me that my x point here is not minus, is actually minus 6. So if I were given this point, I would plug in y minus 10 equals the slope 5/9 times x minus 6, which then becomes the x plus 6. Okay, so here's our answer here for our slope and our 1 point. Problem 2 is the reverse of problem 1. We're asked to write the equation given a point with a slope. Okay, so again, my point slope form looks like this: y minus the y coordinate in the first point equals the slope times x minus the x coordinate in the first point. Okay, so we start here. In other words, this is going to be my x1 and my y1, and this is going to be my m, and all I got to do is plug them in here. So this is going to be y minus, y1 is minus 5, so we put y minus 5, and the slope is negative 3, times x minus, and we have 2. Now the only thing we're going to do differently here is we don't like to leave this here like this, y minus 5. So subtracting a negative number becomes adding the opposite, so that becomes y plus 5 equals minus 3 times x minus 2. And since they just said to write an equation, there's my equation. For problem 3, we're going to do what we did in number 2, find the point, or actually number 1, find the point and the slope and then use it to graph. So let's again remember what my point slope form looks like. It says that y minus the y value in 1 point equals the slope times x minus a value in the first point. So now let's compare our equation. Y minus 5 equals 2 times x plus 3. Now one last thing, notice that in this case both of these were subtraction. So to make this the same here, I'm going to change each of these to subtraction. This one's fine, but here x minus 3, to change that to subtraction, is to subtract minus 3. Okay, now I have my y1, I have my slope, and I have my x1. Or I can write it this way: my slope, m, equals 2, and my point is going to be minus 3, 5. So now we can graph it. We start by graphing the point first. So over here, start at the origin and go -3, 1, 2, 3, and then up 5, 1, 2, 3, 4, 5. So there's my point, -3, 5. And now my graph says my slope is going to be 2. Well, if I'm doing a slope, I could go up here and say, okay, I'm going to go up 1, 2, and over 1. I'm kind of off the graph. But let's go backwards. Let's go down 2 and over 1. And down 2 and over 1 this way. And my actual graph then, slope line is going to go through something like that. Starts at the point -3, 5 and goes up by 2. Problem 3 asks us to write an equation of a line that passes through the points -1, -1, and 1, 5. Well, there's a couple ways to do this. Because we're dealing with an equation of the form point slope, that's what we're studying, we're going to do it that way first. So notice if I write that out, that's y minus y1 equals m times x minus x1. Well, we have a point. Okay, I can let this one be x1, y1, or I could let this one, I could use this one just as well. Okay, and so we could use either of those, but what we don't know is our slope. So let's find our slope first. So you remember that slope is the y in the second point minus the y in the first point, and then the x in the second point minus the x in the first point. So if I list my points up again here, just so you can see them, what I'm doing, here's my x1, y1, and here is my x2, the x in the second point. What I do first is I'm going to do the y2 minus the y1. So that's going to be 5 minus -1. Watch your signs here. And the second x, I'm going to go 1 minus -1. So I'm going to have 1 subtract -1, okay? Now, minus a -1 becomes 5 plus 1, and minus a -1 becomes 1 plus 1. So I end up with 6 over 2, which reduces to 3. So that's my slope. At this point, then, I can plug in one of these points. For example, I could plug in the second point, just so that I don't have a bunch of negative numbers. And I could say, okay, y minus 5 equals, my slope is 3 times x minus 1. So that would be an equation. I could also use the other point, by the way. I could use this point here and say, okay, it's y minus -1 equals 3 times x minus -1. Change these to pluses, and I get y plus 1 equals 3 times x plus 1. So that would be another possible answer. Okay? Those would be our two answers in that form. You remember from our last lesson, we would have done this differently. If you remember when we were doing the y equals in the slope-intercept form, we would have said, okay, I'm going to take y equals mx plus b, and I'm going to put in for the slope, I'm going to put in 3, but then I'm going to put in one of these points here. For example, if I put in for y, I put in the 5, I'm using this point here, equals 3 times the 1 plus b. I get 5 equals 3 plus b, subtract 3, and I get b equals 2. And then I could have written this equation, y equals 3x plus 2. That's another equation of the same line. You might say, well, how can they all be the equation of the same line? Well, take a look at this one, for example, here. If I were to distribute this, I would get y plus 1 equals 3x plus 3. Now, if I subtracted 1 from both sides, notice that I get y equals 3x plus 2. I get the same thing. And if you did that for this one here, if you distributed here, you would end up with the same exact result. They would end up equaling that one too. So all three of these are the same equation. They just haven't been simplified in the same way. This is the vocabulary question. It asks, what features of the graph of the equation can you identify? Well, let me just write it out bigger. First of all, the m is always our slope, okay? On the other hand, the other 2 points, this is x, the x value. Let me erase that a little bit here. This is the x value in the first point. And likewise, this is the y value in the first point. So this would tell me when I see this equation that it goes through the point x1, y1, and it has a slope of m. Okay? That's what those things mean. The x and the y are just the general variables in our equation. Problem 6 asks me if this equation is actually does this point go through it? Well, when I originally look at it, you can see here and go, okay, y minus 3 equals 5 times x plus 1. If I put it in with subtraction, I could have y minus 3 equals 5 times x minus 1, and I would say this is the point. It goes through the point minus 1 here, 3, and has a slope of 5. But that doesn't necessarily tell me that whether that point 113 belongs there. It might not. This just tells me that this point is. So the only way to do it is to plug in this point into the equation and see if I get a true statement. So let's do that. We'll start off here with y. Y is 13. So I have 13 minus 3 equals 5, and my x is 1, 1 plus 1. So let's see if we get the same thing here. So I have 13 minus 3 is 10, and this is 5 times 2, so I get 10 equals 10, which is a true statement. So therefore, I can conclude that 113 is a solution to the equation, and that means it's on the line. It's on the graph of the equation. The point of this meaning that when we look up here, we can find the 1 point being chosen here, minus 1, 3, but there are lots of points on the line. So the only way to find it is to plug in a point and see if it works. Problem 7 asks, can any equation in point slope form also be written in slope-intercept form? And the answer, of course, is yes, it can be. We saw that in an earlier problem. Remember, we saw the 3 equations, and I said they're all the same. And let me give you a simple example. I'll make a real generic example. For example, if I have a point AB and a slope M, I can write the equation y minus b equals m times x minus a. Now notice what I can do. This is in the point slope form. Can I write that in the y equal mx plus b form? Well, let's see. First thing, let's distribute. And I get y minus b equals mx minus ma. Now let's add b to both sides. And I get y equals mx plus, and I'll put it all together here, b minus m times a. So notice in this case, here's my here's my y-intercept here, and here's my slope, and this is now in the slope-intercept form. So that's generic. Let me just pick a number to show you again how this might work. Let's suppose I picked a point like this. Y minus 2 equals 3 times x minus 5. Okay, that's point slope. And to make it into a slope-intercept, we'll distribute again. Y minus 2 equals 3x minus 15. And then we'll get the y by itself by adding 2 to both sides. And we end up with y equals 3x minus 13. And now I'm in slope-intercept form. And that procedure can be done for any time you want to go from point slope to slope-intercept. The next couple problems are graphing problems. They'll remind you somewhat of when we were graphing with the slope-intercept. We would always find the y-intercept and then use the slope to find another point. Here, instead of using the y-intercept, we're going to use the point they give us. So we start with this point, and we're going to go to the origin, and x is minus 4, so I count to the left, 1, 2, 3, 4. Y is minus 3, so we go down 3, and there's my first point. And the point is, of course, minus 4 minus 3. Now we have a slope of 2, which is the same as 2 over 1. That's my change in y. I go up 2, and my change in x is 1. So if I draw me a little slope triangle, I'm going to go up 2 and over 1, and that'll be my next point. And that I can draw my line. Now, because I don't have a ruler here, I'm going to go ahead and kind of sketch out where we're going to go next. If I go up 2 and over 1, there will be a point. Up 2 over 1. I can even go down 2 and back 1. And that helps me draw my line straighter since I don't have a ruler. And there's our graph. Problem 9 is just like problem 8. Let's begin with our point. And we'll put that on the graph. So I have x is 7. So 1, 2, 3, 4, 5, 6, 7. That's not going to be real great for us. Minus 2 is down here. The graph's obviously not big enough. And then we're going to have minus 5, 3 is our slope. So I can change that to say I'm going to go down 5 and over 3. Now in my case, because I'm already off the graph here, from this point, I'm going to go back 3, 1, 2, 3, and up 5. 1, 2, 3, 4, 5, and that will be my graph there. Fortunately, on your homework, this point stays on there, but notice I can go back 3 and up 5, and now my graph is going to go through those 2 points there, and we're going to get a graph that looks something like this. So we use the point as our starting point, and we use the slope to find the next point, and then we connect the lines. Problem 10, again, is like problem 8 and 9. We're going to start with the point and graph our first point. X is minus 4, so from here go back 4, 1, 2, 3, 4, and then y is positive 2, so we go up 2. There's our first point. Our slope is 1 over 3. All right, so that's the change in y. It goes up 1 and goes over 3. So from this point, I'll go up 1 and then over 3, and that's going to be my next point right there. If I want to make my sketching easier, I go up 1 over 3 again, up 1 over 3 again, and I can keep mapping out points that way that make it easier for me to draw without a ruler, and then my line goes through those points like that. Starts at this point here, minus 4, 2, has a slope of up 1 over 3. Problem 11 is not a hard problem, but it does take a little bit of work. The first part, they say, here's a rectangle, all right? And they want to write equations in the point slope form for the lines containing. So let's start with line AB, okay? Line AB here. I notice that it starts at this point here, and this is the point negative 1, 2, 3. This is negative 3, 1. What's the slope of the line here? Well, notice if I draw my little slope triangle here, I have plus 2, 1, 2, 3, 4, 5, 6, plus 6. So my slope here is 2 over 6, which is 1 over 3. Okay, so I have that point, so I can now write an equation. My equation using the point slope formula is going to be y minus 1 equals 1/3 x minus 3, or I would write that equation as y minus 1 equals 1/3 x plus 3. So that's my first equation. All right. Second equation, let's look at, well, let's just start answering some questions. Well, let's go ahead with BC. So BC, I'm going to use the point B here. Point B is the point 1, 2, 3, 3, 3. So B is the point 3, 3. Okay. So my point is 3, 3. And what's my slope? Okay, my slope, notice it goes down 1, 2, 3. It goes down 3 and over 1. So my slope is minus 3 over 1, or just minus 3. So my equation is going to be y minus 3 equals minus 3 times x minus 3. And that's my equation for that line. Okay, let's go on to CD. And I'm going to pick the point C here. This is going to be the point 1, 2, 3, 4. This is the point 4, 0. By the way, on each of these, I could have used point D as C. I would get the same answer. The equation would look a little different, but they would simplify to the both. Now look at my slope on this one. If I look at my slope here, and I'm going to go down just to keep it cleaner. It goes from here to here. It goes up 2. See, it goes up 2 and over 1, 2, 3, 4, 5. It goes over 6. So my slope ends up being 2 over 6, or equal 1/3. Notice that this and this are the same. All right. So that means these two lines are parallel. They have the same slope. But let's go and write our equation now. So our equation is y minus 0 equals 1/3 times x minus 4. Or you could simplify that and say y equals 1/3 x minus 4. And then our last form, dA, our last line. And notice here again, I'm going to start with point D. No reason for that in particular, but minus 2, minus 2. So minus 2 is one of the points I'm using. And the slope, and this shouldn't surprise us here. If I go from here to here, it goes down 3 over 1. So it's going to be minus 3 over 1, or minus 3. And again, notice that's the same as this one, because these two lines are parallel as well. So let's write our equation. Y minus 2 equals minus 3 times x minus 2. But minus a minus becomes y plus 2 equals minus 3x plus 2. And that's the equation for our fourth line. All right. Now, just as we've gone through, we've realized these opposite lines are parallel, meaning that they have the same slope. So it says, use your conjecture to write an equation of the line that passes through 0, 4 and is parallel to this equation. Well, if the two lines are parallel, they have the same slope. So notice here the slope is minus 7. So let me call this C. So if I want to write one going through this point, I'm going to use this point and this slope. So my equation would be y minus 4 is going to equal -7, there's my slope, times x minus 0. Or I could change minus 4 to y plus 4 equals -7x, and that's 0. And that would be my answer for part C. All right, so that takes care of our homework tonight. Hope it helped you a lot. See you in class.